The following technologies are used to load data to SAP BW. Operational Data Provisioning or ODP, to provide data via the ODP Data Replication Application Programming Interface or API from different sources such as SAP ERP Extractors, SAP BW, SAP HANA Views, SAP Business by Design, SAP Landscape Transformation Replication Server or SLT, BW Service API or S-API. The Service API is a technology package in SAP source systems of BW which facilitates a high level of integration for data transfer from the source systems to SAP BW. Therefore, it allows for communication between SAP source systems and SAP BW. The Service API is installed on the SAP source system as part of the software component SAP Basis plugin. DB Connect allows relational databases to be accessed directly. Here, DB Multi-Connect is used to create a connection to the Database Management System or DBMS in the external database. By importing metadata and original data, the necessary structures can be generated in SAP BW and the data can be loaded easily and efficiently. UD Connect. Using UD Connect, you can access almost all relational data sources. This technology runs on the J2EE engine and supports the J2EE connector architecture. File Interface. SAP BW supports automatic import of files in CSV, ASCII, and XLS format for flat files. Web Services. Web services permit you to send data to SAP BW under external control. SAP Data Services, to use its tight integration when providing data via staging business application programming interfaces or BAPIs. Staging BAPIs. Staging BAPIs are open interfaces which SAP Data Services and certified third-party tools can use to extract data from older systems. The data transfer can be triggered by a request from SAP BW or by SAP Data Services or a third-party tool.
Flow and process design concepts in SAP BW consists of a transformation, an info package for loading data to the persistent staging area or PSA, and a DTP for data distribution within BW. In the data source maintenance of the data source object in BW, determine which data source fields should be transferred. Those are the fields which contain the information relevant for decision making in a business process. Upon activation of the data source, a PSA table is generated in the entrance layer of BW and data can then be loaded. In the transformation, determine the appearance of the assignment of fields from the data source to info objects from BW. DTP facilitates the further distribution of the data from the PSA to other targets. The DTP rules which are set in the transformation apply in the transfer. The figure highlights the role played by the data source in data acquisition in BW as the central object for data acquisition in BW.
In SAP BW, the data acquisition layer is represented by the PSA. The PSA is a mandatory component of the data flow. It is the inbound storage area in BW for data from the source systems. The requested data is saved unchanged from the source system. Request data is stored in the transfer structure format in transparent relational database tables of the BW system in which the request data is stored in the format of the data source. The data format remains unchanged, meaning that no summarization or transformations take place as is the case with InfoCubes. The possible coupling of the load process from the further processing in BW contributes to an improved load performance. If errors occur when data is processed further, the operative system is not affected. For best practice, it is recommended to use the PSA to decouple the extraction load process from BW data staging. Provided the affected part of the Enterprise Data Warehouse or EDW layer is stable, it is no longer necessary to save the raw data for days or weeks in the layer is stable, it is no longer necessary to save the raw data for days or weeks in the PSA. With SAP BW 7.4, loading data from operational data provisioning or ODP source systems directly to InfoProviders with DTPs is possible. In this context, the PSA is optional again.
The transformation process allows you to consolidate, cleanse, and integrate data. You can semantically synchronize data from heterogeneous sources. When you load data from one BW object into a further BW object, the data is passed through a transformation. A transformation converts the fields of the source into the format of the target. You create a transformation between a source and a target. The BW object's data source, InfoSource, data store object, InfoCube, InfoObject, InfoSet, and multi-provider serve as source objects. The BW objects, InfoSource, InfoObject, data store object or DSO, and InfoCube serve as target objects. The figure illustrates how the transformation is integrated in the data flow.
An InfoSource is a non-persistent structure consisting of info objects for joining two transformations. You use InfoSources in the data flow concept if you want to run two sequential transformations in the data flow without storing the data again. If you do not have transformations that run sequentially, you can model the data flow without InfoSources. InfoSources should be used in the following scenarios. If you want to execute two transformations before data is written to the InfoProvider, you need an InfoSource to join these two transformations. If you want to update data from several sources, more than one data source for one or more source systems, it is useful to consolidate the data in an initial transformation at InfoObject level. In a second transformation, perform transformations which are independent of the data and are valid for all data. This allows you to react in a flexible way to changes that are not data source dependent. The figure shows the objects of both data flow concepts, the 3.x data flow based on a 3.x data source and the new data flow based on the new data source. Note that you cannot have a 3.x data source and a new data source object for the same data source in SAP BW. You always have to decide whether you want to work with a 3.x data source or with a new data source object.
The target of the data flow is an InfoProvider. The data target InfoProviders include the following: InfoCubes, data store objects, master data. The data target InfoProviders are made up of physical database tables. Multi-providers and InfoSets are logical InfoProviders that are based on other InfoProviders. A multi-provider is a database union and an InfoSet is a database join of the tables of the other InfoProviders. A virtual provider is an InfoProvider that is defined in BW, but the data resides in an external system. Queries in SAP BW are based on InfoProviders, both physical and logical. Front-end client tools enable robust analysis and reporting functions. You are implementing a project that requires transaction data to be sent from an SAP source system to your SAP BW system. Before you start working on the details of this specific task, you need to know the basics of the SAP BW ETL. The extraction, transformation and load or ETL process, sometimes called the data flow, is a list of the steps that raw or source data must follow to be extracted, transformed and loaded into SAP BW targets. The basic BW data flow is the process of taking data from a source system, applying transformation rules to it and loading it to a BW InfoProvider, that is, data target. Info packages and the DTPs are the SAP BW objects that facilitate the actual movement of data through the ETL process. Every path from persistent source to target is a DTP. Info packages load data from the source system to the PSA without any transformation. Info packages and DTP should be included in a process chain to automate the loading process.
A source system is any system that is available to SAP BW for data extraction and data transfer purposes. Data sources are SAP BW objects used to extract and stage data from source systems. Data sources subdivide the data provided by a source system into self-contained business areas. A data source contains a number of logically related fields that are arranged in a flat structure and contain data to be transferred into SAP BW.
Generic data sources for transaction data, master data attributes or texts can be created from any transparent table, database view or SAP query info set or using a function module. This allows you to extract data from any application generically.
A PSA is created for each data source and source system. It represents an initial store in SAP BW where the requested data is saved unchanged from the source system. Technically, a PSA is a transparent database table in which request data is stored. To view requests in the PSA, from the data source context menu, select Manage. Requests can be deleted from the PSA by selecting the request and pressing the delete icon. There is a maintenance screen for data records in the PSA. PSA data records may be changed, provided that the request has not yet been extracted.
Source system data is integrated into SAP BW with transformations where the field mapping from source to target is handled. With transformations, data is copied from a source format to a target format in SAP BW. Transformations can also include data cleansing and consolidation from multiple sources. Once the data flow is designed, the info packages and the DTP manage the execution and scheduling of the actual data transfer. The first process is loading the data from the source system. This involves multiple steps that differ depending on which source system is involved. The info package contains the selection parameters for transferring data into the PSA. The DTP controls the actual data flow, such as filters, update mode, that is delta or full, for a specific transformation.
Semantic groups define the key fields of the error stack. When the DTP is executed, all records belonging to the same semantic group are extracted into the same DTP data package. Since the serialization of records is ensured within a given data package, this secures serialization of records belonging to the same semantic group, even if different packages are handled in parallel. DTP error handling in combination with semantic groups is explained in greater detail in BW 310 Enterprise Data Warehousing. A data flow in the data warehouse displays a set of metadata objects and their interrelationships. The relationships are displayed using transformations or are contained directly within the objects, as with multi-providers, for example. The data flow specifies which objects are required at the design time, for example, modeling objects, and which processes and transformations are required at runtime, for example, runtime objects, to transfer semantically related data to SAP BW, where the data can be integrated and consolidated. The modeling functional area of the data warehousing workbench displays SAP BW objects and the corresponding data flow in a structured way with object trees. The modeling functional area consists of various screen areas as well as the menu, title, and status bars. The modeling screen contains the following 4 screen areas: modeling button bar, navigation pane in the left-hand area of the screen, view of selected object tree in right-hand area of screen, and with open applications, the middle area of the screen. Open application in the right-hand area of the screen. The data flows are organized using info areas. The folders organized by object type underneath a data flow show which persistent objects, including runtime objects and transformations, are contained in the data flow. The complexity of data flows varies. At a minimum, you need a data source, a transformation, and an info provider. A graphical user interface in the data warehousing workbench facilitates building data flows and data flow templates. The graphical data flow feature enables graphical top-down and structured modeling directly in SAP BW.
Data transfer in SAP BW 3.x utilized an object called a data source 3.x. Data transfer was only possible when the data source 3.x was assigned to an InfoSource 3.x and the fields of the data source 3.x in the transfer structure maintenance info objects were assigned to an InfoSource 3.x. Data source 3.x. Up to SAP BW 3.x, data sources were known as replicated data sources. When the transfer rules 3.x are activated and thus the transfer structure 3.x, a PSA table is generated into which the data can be loaded. The figure provides an example of this with a flat file data source and a data source that has been replicated from the SAP source system. For data source 3.x, the transfer structure is used to move the extracted data to the communication structure with the transfer rules. Activating the transfer rules in SAP BW generates the transfer structure. With an SAP source system, The transfer structure is also generated in the SAP source system, that is, metadata download. If your data flow is modeled with objects based on the SAP BW 3.x concept, such as InfoSource 3.x, Transfer Rules 3.x, Update Rules 3.x, and the process design is based on these objects, you can continue to work with Data Sources 3.x to transfer data into SAP BW from a source system.
An InfoSource 3.x is a number of logically related info objects and stages consolidated and transform data for updating to the SAP BW data target.
With an InfoSource with direct update, master data, attributes, text data, or hierarchies is updated directly, in other words, without update rules 3.x to the corresponding master data tables for a characteristic InfoSource 3.x after leaving the corresponding communication structure. You must assign the characteristic info object to an application component in the maintenance screen for the characteristic info object master data / texts tab page or in the InfoSource tree using the context menu for an application component. From a technical point of view, this InfoSource 3.x type includes logically related fields which are offered in 3 flat structures as an option. The communication structures for attributes, texts, or hierarchies. These structures serve to update the data to the master data tables for the characteristic info object.
In the case of an InfoSource with flexible update, update rules are used to update the data from the communication structure to the data target assigned to it, that is, standard InfoCube data store object or characteristic info object. Several data targets can be supplied from this kind of InfoSource. You can use this InfoSource to update master data, attributes or texts, and transaction data. Similar to an InfoSource with direct update, this InfoSource type is created in the InfoSource tree in the data warehousing workbench using the context menu for an application component. Caution: hierarchies cannot be updated using an InfoSource with flexible update. Transfer rules are defined in BW for harmonizing or cleaning up data from the transfer structure to the communication structure. The prerequisite is that one or more data sources are assigned to an InfoSource, though the transfer rules are defined for each data source. This means that transfer rules are data source specific and consequently source system specific.
The following figure shows the maintenance screen for transfer rules. When defining transfer rules, you can choose between the following 2 transfer methods: PSA or persistent staging area, IDOC or intermediate document. The transfer method only determines how the data is transferred. Both methods are compared in the following table.
This section describes scheduler update options.
Transformations are needed to update data that specify the transfer of the data from the InfoSources communication structure to the data targets, that is, physical InfoProvider. To distinguish them more clearly from the transfer rules, these transformations are described as update rules. You must create update rules if you supply a data target from an InfoSource with a flexible update. Create update rules in the context menu for the respective InfoProvider in the data warehousing workbench. Only standard InfoCube, standard data store object, and characteristic info object, that is, attributes or texts, data targets can be used as data providers here. A data target can be supplied by several InfoSources. You must maintain a set of update rules for each InfoSources which describes how data is written from the InfoSources communication structure to the data target.
The update method describes the form in which the values of a characteristic or key figure info object, a data field or key field, or an attribute or key field are determined or calculated for updating to the data target, such as standard info cube or data store object or characteristic info object. The following options are available.
The update type controls whether and how a key figure, data field, or attribute or text is updated in the data target, such as standard info cube, data store object, or characteristic info object with an individual key combination. This section explains the update types for data store objects. This section explains the update types for characteristic info objects such as attributes or texts.
The figure compares the possible aggregation types in relation to the respective data target type. Hint: similar to the transfer rules, you have the option of creating a start routine in update rule maintenance. The start routine is run for each data package and before the update rules are executed. The SAP BW 3.x Dataflow objects such as 3.x data sources, 3.x transfer rules, update rules, and 3.x InfoSources continue to be supported. The following table shows a comparison of the concepts. Emulation before migration is used to model and test the functionality of the SAP BW 7.x data flow with transformations without changing or deleting the objects of the existing data flow, and serves as a first step to migrating 3.x data source to data sources in SAP BW 7.x. As a prerequisite, the 3.x data source to be migrated must be active along with the transfer structure and transfer rules. An emulated 3.x data source can be displayed in data source maintenance in SAP BW. Changes are not possible in this display. In addition, you can use emulation to create the data flow for a 3.x data source with transformations without having to migrate the existing data flow that is based on the 3.x data source. To display the 3.x data source emulated in the data source maintenance, mark the 3.x data source in the data source tree and choose Display in the context menu. To create the data flow using transformations, mark the 3.x data source in the data source tree and choose Create Transformation in the context menu. You set the target for the data transfer from the PSA table using the transformation.
You can migrate a BW 3.x data source to a BW 7.x data source. If the 3.x data source already exists in a data flow for the SAP BW 3.x concept, you use emulation first to model the data flow with transformations and DTP and then test it. Subsequently, you can deactivate the data flow you were using before and delete the metadata objects during migration.
You perform migration in the original system. You import the transport for the migration into the target system according to the following steps. In the original system or development system, in the data warehousing workbench, in the context menu of the data source 3.x, choose Migrate. If you want to restore the data source 3.x at a later time, choose with Export on the next screen. Specify a transport request. Transport the migrated data source to the target system, that is, quality system and productive system.
If you exported and archived the 3.x metadata objects when you migrated the 3.x data source in the original system, you can restore the SAP BW 3.x data source from the migrated BW 7.x data source. The system reproduces the 3.x data source mapping and transfer structure objects with their pre-migration status.
Direct access to data in BW source systems without extraction is available using virtual providers. Virtual providers are InfoProviders with data that is not stored in the object itself, but which is read directly during reporting. The relevant data can be from the BW system or other SAP or non-SAP systems. Virtual providers only allow read access to data. Various virtual providers are available depending upon their use in these different scenarios. Virtual providers based on DTP, virtual providers with BAPIs, virtual providers with function modules.
The figure illustrates that queries based on virtual providers provide access to data without extraction and storage. This type of virtual provider is defined by its data source or info provider and takes on its characteristics and key figures. Unlike other virtual providers, you do not need to program interfaces in the source system. You use the same extractors to select data in the source system as you use to replicate data into the BW system. When you execute a query, every navigation step sends a request to the extractors in the assigned source systems. The set of characteristics together with their selection criteria are transformed according to the transformation rules to fields of the transfer structure. They are passed on to the extractor in this form. The delivered data records pass through the transfer rules in the BW system and are then filtered in the query again. Note, if master data and hierarchies are not read directly by the source system, they need to be available in the BW system before you execute a query.
Using this virtual provider, you can carry out reporting on data in external systems without having to physically store transaction data in the BW system. You can, for example, include an external system from market data providers using a virtual provider.
You use this virtual provider with a user-defined function module. If you want to display data from non-BW data sources in BW without having to copy the data set into the BW structures. The data can be either local or remote. You can also use your own calculations to change the data before it is passed to the analytic engine. This function is used primarily in the SAP Strategic Enterprise Management or SEM application. In comparison to other virtual providers, this virtual provider is more generic. As such, it offers more freedom but also requires more implementation effort.
In BEX queries, you can use hierarchies with direct access. This is recommended for small hierarchies which do not change often. If the query that uses the hierarchy with direct access is executed, the system compares the hierarchy header data in the buffer with the hierarchy header data in the source system. If the data in the source system is more current than the data in the buffer, the entire hierarchy must be read into the buffer.
Direct access should not be confused with direct loading. It is possible to load data directly into the target without using the PSA. Thus, no info package is required. However, this is an exception scenario, since data can be loaded only using a full DTP, and thus only small amounts of data can be handled. In addition, DTP error handling cannot be used. Nevertheless, data is loaded to BW and stored in the data target. Real-time data acquisition supports tactical decision-making. In terms of data acquisition, it supports operational reporting by allowing you to send data to the Delta Queue or PSA table in real time. Use a daemon to transfer data into InfoProviders in the operational data store layer at defined intervals. The data is stored persistently in SAP BW. Real-time data acquisition can be used in different scenarios. Note that this lesson focuses on SAP I and web services data sources in later units. Hybrid providers and ODP data sources will be introduced in an RDA context. Via the service API or SAPI, which incorporates the usage of info package for real-time data acquisition, that is, source to PSA. It then leverages the DTP for real-time data acquisition, PSA, to DSO. Via a web service, which incorporates usage of web services to populate the PSA. The real-time DTP is then leveraged to transfer data to the DSO. The figure illustrates the process flow for the real-time data acquisition using SAP applications.
The figure depicts real-time data acquisition with web services. Data is loaded into SAP BW at frequent, regular intervals and is then posted to the DSOs that are available for operational reporting. In SAP BW, special info packages are created for real-time data acquisition. These are scheduled using an assigned daemon and are executed at regular intervals. With certain DTPs for real-time data acquisition, the daemon takes on the further posting of data to DSOs from the PSA. As soon as data is successfully posted to the DSO, it is available for reporting. To display the up-to-date data, refresh the query display. The query displays the time that the data was last refreshed by a daemon run, even if no new data has been posted. You can transfer data from the source to the entry layer of SAP BW, that is the PSA, in the following two ways. You use the web service to push the data from the source into the PSA directly. In this case, the data transfer is therefore controlled externally without being requested in BW. An info package for full upload is only required to determine specific parameters for real-time data acquisition. When the delta queue in the source system requests data, the data is loaded into the PSA using an info package created specifically for this purpose. You must perform the initialization of the delta process for the data source beforehand. The following two scenarios are possible. The application in the source system writes the data to the delta queue, for example, V3 update for logistics information system or LIS data sources. In this case, the daemon receives the data without calling the extractor. The data is not automatically written to the delta queue. With generic extractors or extractors that transfer data synchronously from SAP BW to the SAPI on request, the daemon calls the extractor and extractor writes the data to the delta queue. The data is transferred to SAP BW directly from the delta queue. The requests for info packages and DTPs are synchronized and remain open throughout several load processes. They are only closed when the size and time limits set in the info packages are exceeded. The DTP copies these settings from the info package. When requests are closed, new requests are opened automatically and the data transfer for real-time data acquisition continues with these new requests. The data and the open requests are available in reporting as soon as they have been successfully posted to the DSO. To synchronize master data and transaction data when using real-time data acquisition, you have to be able to transfer master data to SAP BW using real-time data acquisition. If master data and transaction data are not synchronized, the navigation attributes for the data may be missing or incorrect. A daemon is a background process that processes the info packages and DTPs assigned to it at regular intervals. It is used to control the transfer process for real-time data acquisition. The daemon receives information from the info package and DTP about which data is to be transferred or updated further, which PSA tables or DSOs are to be filled, and when a request should be closed and a new one opened. When you extract data, the daemon works on the basis of the list of data sources assigned to it in the info package. The daemon extracts the data from the source systems and transfers it to the PSA table and DSOs. The info package definition for SAP applications is shown in the figure.
The daemon informs the service API in the source system when the data for the source system has been successfully updated, when the PSA request has been closed successfully and a new delta request has been opened. The updated data is deleted from the delta queue of the source system. When you further update data to the DSOs from the PSA, the daemon works on the basis of the list of sources such as data sources and targets such as DSOs assigned to it in the DTP. It transfers data to the DSO. The data is written straight to the active data table and the change log table. If the extraction or update is terminated, the daemon can restart the process from the point at which it was terminated. In the case of DTPs, you can determine the maximum number of errors that are allowed before the process is finally terminated. The following figures depict the process of extracting data every 3 minutes. The figure illustrates the activities on the SAP application side.
The Daemon then triggers real-time data acquisition processing from the application as illustrated in the figure. The following lists outline the steps the Daemon initiates. RDA runtime step 1. Call source system for new records. Status update of transferred records in confirmation table. Update PSA. Commit. Update confirmation table and update PSA in one step. Guarantees synchronization. After the confirmation table and the PSA are updated. RDA runtime step 2. Check for records in confirmation table. If records are available in confirmation table, the corresponding records exist as well in PSA. Daemon flags records in source system. Replay confirmation sent to SAP BW. Entries are flagged as processed in confirmation table. Commit. If not successful in BW, records will stay in confirmation table. Guarantees restart of step 2 even when the update in the source system was successful.
The figure illustrates the daemon triggering RDA processing 3 minutes after the first initiation.
The Daemon runs in a permanent background job and only switches to sleep mode after performing a data transfer if there is currently no other data in the Delta queue and no other data being posted to the PSA by a web service. If the SAP is being used to transfer the data, the RFC connection to the source system remains open. This implies that a permanent RFC connection between every source system and SAP BW is required for real-time data transfer using the SAP I. Note, to prevent the system using too much main memory and so that the RFC connection does not have to be open for too long, the Daemon stops itself on a regular basis and schedules again so that the main memory can be released and a new RFC connection can be opened. This happens without having to close the request for real-time data acquisition. In the monitor for real-time data acquisition using transaction RSRDA, the daemons that are currently available in the system are displayed in a tree structure. Info packages and DTPs are displayed below their data sources. The monitor displays the status of the daemons and the assigned info packages and DTPs along with their open requests. It also includes the monitor functions for processing the daemons and the info packages and DTPs. To access the real-time monitor in the data warehousing workbench in the administration functional area, choose Monitors, Real-Time Data Acquisition. Under a daemon, the system displays the data sources which are used to load data with real-time data acquisition that already have an info package for real-time data acquisition. Data sources with info packages that are not assigned to a daemon are displayed under unassigned objects. Under a data source, the system displays the info package that contains the parameters for the data transfer along with the DTP that uses this data source to fill a DSO. Under an info package or DTP, the system displays the open requests that post data to the PSA table or DSO. To update the overview, choose
An info package for real-time data acquisition starts the transfer of data from a data source. Data is transferred into the PSA by a real-time info package and then is transferred to a DSO with a real-time DTP. Web services-based real-time data acquisition is the following two-stage process. Data is pushed into the PSA using a web service. Data is transferred to a DSO using a real-time DTP. The figure illustrates the real-time data acquisition process using web services.
A Daemon monitors the PSA and initiates the DTP on a regular basis according to settings in a real-time info package. The info package is needed for the web service to define parameters such as time or record thresholds for request closure and to allow the assignment of a Daemon using the real-time monitor as seen in the figure.